Okay, 15.1, understanding geometric sequences, sorry. So here we're going to look at some more of the whole idea of math is patterns. So this is patterns, but they're not linear patterns or not arithmetic. Okay, remember we did arithmetic that dealt with linears. These are not linear. These are what we will refer to later on as exponential functions. So we're going to go through this. There are a couple words here: common ratio, geometric sequence. Again, we'll use some different terminology here as we go through. So let's look at how to find this common ratio. Now, before we do that, this is what we use in terms of, it's referred to as a recursive formula. Sorry, can't get my screen to cooperate. Okay, a recursive formula. Now, all that means is to get the next term, I have to use the previous term. That's what the n minus 1 means, okay? Previous term. So when it was an arithmetic sequence or linear, that meant we were adding or subtracting something, the same amount every time. So it was our slope. Here in geometric, we have this common ratio, r. It's what we're multiplying by. Okay, so how do we get that? So let's look at these your term problems here. It says find the common ratio r for each geometric sequence and then use r to find the next 3 terms. Okay, so we're going to look at some notation here as well. So all we do is we look very similar to arithmetic. What's happening here? Now, some cases it's real easy to see. Like here we know it's multiplied by 4. Okay, that's what it is. That's what r is. So r is 4. But if you're not sure, if it's harder to look at, and we'll do number 6 in which that's the case, what you do is you take the second term and divide it by the first term. So if I do that, I get 4, the same thing here, okay? So sometimes you can look at it, and sometimes you may actually have to kind of quote-unquote solve for it. So if that's our common ratio, how do we get the next 3 terms? So this is referred to as term 1. This is term 2, term 3. So we use this function notation. This would be term 4. So to get term 5, all I do is I take the previous term. This is that recursive formula. You take the previous term and you multiply it by whatever your r is. So if you do that, you're going to get 1280. Okay, so then we do the next one, f of 6. Again, we multiply by 4. And here's where you know, it might be necessary to use a calculator to kind of help you find these values. But 1280 times 4 would be 5,120. And then you find f of 7, so because we're doing the next 3 terms. So then we do 5,120 times 4, and we get 20,480. So not bad, just patterns. So let's look at problem number 6. So in problem number 6 here, it's a little bit harder to see. Now you look and you say, okay, it's getting smaller, so you're dividing, but they don't treat it as division. They're always treating it as multiplication. So if you have trouble here, again, take the second term, divide it by the first term, and then simplify. So that's negative 1/3. That's our r. So they give us the first 4, so to find term number 5, I take the previous term, which was negative 1/3, and I multiply that times my r, which is negative 1/3, and that gives me 1/9. Then to get f of 6, I take the previous term, which was 1/9 now, multiply it times my r, and now I get negative 1/27. And then to find the 7th term, or the 3rd term, next 3rd term, I take that amount, negative 1/27, multiply it times the r, which is negative 1/3, and then that gives me 1/81. Okay. So those would be my next 3 terms in the sequence. All right, so moving forward, obviously you can look at the word problem here to figure, refer to some things, get some reference, but we're just going to go straight to the your turn problem on this and do this one. Okay, so it says a ball is dropped from a height of 8 meters. The table shows the height of each bounce. The heights form a geometric sequence. How high does the ball bounce in the fourth bounce? Okay, so first thing we want to do is look and think logically. If you're bouncing the ball is going to bounce less high, so it's going down. Now, what that tells me is if it's going down, then that means my R has to be something that is a fraction less than 1, okay? A fraction less than 1. So think about it in terms of linear. If something's going down, it has a negative slope. If it's going up, it has a positive slope. Well, when we're talking about a geometric, okay, or an exponential function, as we'll learn later on, then that means R is, if it's going down, has to be a fraction value. If it's a going up, then it's something bigger than 1, something greater than 1. So again, how do we do that? We take the second term and divide it by the first term. So 4.5 divided by 6. So if I do that on the calculator, and that gives me 3/4. So that's my R. Okay. So now I use that to find the fourth bounce. Okay, so the fourth bounce is just going to be the next term in the sequence. So to get term number 4, I take the previous value, 3.375, and I multiply that times my R, 3/4, and it says round to the nearest tenth. So 3.375 times 3/4, and that rounds to 2.5. So I need to do approximately 2.5, and that's in meters. So on the fourth bounce, it would be at 2.5 meters. So not a bad lesson at all. Hopefully you kind of followed all that. And when we get into do some of the homework practice problems.